Now children, let's study about sign conventions. What are sign conventions? They are a set of rules to set signs for image distance, object distance, focal length, etc. for mathematical analysis of image formation. According to it, object is always placed to the left of lens. All distances are measured from the optical center of the lens. Distances measured in the direction of incident ray are positive and distances measured in the direction opposite to that of the incident rays are negative. Distances measured along y-axis, that is, above the principal axis, are positive, and that measured along y-axis, that is, below the principal axis, are negative. Convex lens has positive focal length and concave lens has negative focal length. Now here you will get a clearer view of what we discussed now. Now see, this is an object. So this is measured above the principal axis. That means the height of the object will always be taken as positive. This is, let's say, a image being formed. Then this is measured below the principal axis. That means it will be taken as negative. Now, this object, the light is moving towards this side. So this object distance, this is the direction of light. All distances are to be measured from the optical center. So if you want to measure this distance, this will be against the direction of light. So this will be negative distance. And all those distances which are measured on this side, because we measure from the optical center, we measure this side, are taken to be positive distances. So anything which is measured against the direction of light is taken to be negative, and anything which is measured in the direction of light is taken to be positive. Same is with the concave lens. Anything which is above the principal axis is taken as positive, which is below the principal axis is taken as negative. Similarly, all distances which are measured in the direction of incident light are measured as positive, and against the direction of light are negative. And all distances are to be measured from the optical center, either this way or this way. So this is how we apply the sign conventions to the convex and concave lenses. Now let's study lens formula. What is the lens formula? The equation relating the object distance u, the image distance v, and the focal length f of the lens is called the lens formula. Assumptions made for writing this formula. The lens is thin. The lens has a small aperture. The object lies close to the principal axis. The incident rays make small angles with the lens surface or the principal axis. Now, what is object distance? Object distance is the distance between the object and the optical center and is represented by the symbol U. What is image distance? Image distance is the distance between the optical center and the position of the image. It is represented by the alphabet V. And focal length, you already know, is given by F. Distance between the optical center and the focus is the focal length. So, the lens equation is 1 upon F is equal to 1 upon V minus 1 upon U. So, this is the lens equation, and when we use this equation, then we apply sign conventions. Linear magnification for lens. The ratio of the size of the image formed by refraction from the lens to the size of the object is called linear magnification produced by the lens. It is represented by the symbol M. The size of an image formed by a lens varies with the position of the object. The simplest way to compare the image with the object is by the ratio of their sizes. This ratio is the linear magnification. The ratio of the size of the image to the size of the object is same as the ratio of the image distance to the object distance. Now, linear magnification is defined as the ratio of the image height to the object height. So, over here you have magnification M is equal to I upon O, right? That is height of the image upon height of the object. And see, by using similar triangles concept, we can prove that this I upon O will be equivalent to V upon U. That is the distance of the image to the distance of the object. So, M is also equal to minus V upon U. So, remember, magnification is size of the image upon the size of the object, or you may write it as I upon O. Or magnification is equal to size of the image upon size of the object equal to image distance upon object distance.